The zonal statistics operations are amongst the most powerful in raster data processing. As someone like me who lives in vector data space for a majority of the time, the zonal statistics table, the zonal statistics serves as an excellent conduit between going back and forth between my vector and my raster. I kind of assimilate these zonal statistics as my summarized statistics in my vector. Very powerful tools in which you can do a number of different things at the same time. What we're looking at here in my map is my fishnet here for Durham County. So I created a fishnet and I'm going to calculate some type of land cover. In previous fishnet videos, I've talked about the power of fishnets, where that they're treated as cells. They are kind of spatially neutral because they're all the same size and shape, but you can collect multiple attributes with those, which you can't necessarily do with vector data. What I'm looking at here is national land cover data that's clipped to the boundary of Durham County and also clipped, and you can see these quadrats that we've created for Durham County right here. And you can see the land cover classifications here. This is based off the Anderson classification scheme. There's about 10, 12 different classifications. This has been exported for Durham County, and we've got about a 40-meter cell size resolution for these as well. So you can see some of the open water, developed open space, barren land, deciduous forest, mixed hay pasture, woody wetlands, emergent herbaceous wetlands for Durham County. There's a couple of others that exist for other climate regimes, but not here for Durham County. The other thing that I have here is, and I just extracted out developed land. So I ran a raster operation in which I just picked out the developed open space, low intensity, medium intensity, and developed high intensity. And you can see these are NLCD classifications number 21, 22, 23, and 24. And so these are extremely, you can see the numbers attached to these here, but they're just merely nominal classifications attached to these, so they really don't have any value. The 21 isn't any worse or better than the 22 versus the 23 versus the 24. And we're going to do a couple of different things with these zonal statistics as table operations within our raster or spatial analyst tools. And so I've got a 0, which represents it's not developed, a 1, which represents that it is developed. And if I were to just kind of check this, you would see anything that is, pink or red here is going to be a 1 versus everything that isn't, which is going to be, just a 0. Now, to access the zonal operations, I have my spatial analyst tools. And then down here, I have my zonal operations. For now, I'm going to focus specifically on my zonal statistics as table, because I think that's extremely powerful. We can run some, zonal histograms, zonal statistics, which will create just another raster service. But I want to service this. I want to create a conduit between my vector data here, which I have for my fishnet. So if I were to right mouse click and open up my fishnet, you can see I've got 847 of these quadrats. Now, if you remember, or if you refer to my fishnet application or fishnet video, I created fishnets for all of Durham County. These are at 1 kilometer by 1 kilometer resolution, and then you can see I've clipped it, so I've got kind of portions of these that are clipped at the boundary right here, because we have this odd shape of Durham County and most counties for that. You can see I've got an object ID, because we're gonna have to refer back to that in a little bit here. So I'll show and highlight some of the things that I want to do, because what I want to do is for each of these quadrats, I want to calculate the percentage of developed land. I want to see which of these pixels appears the most. We've done some prior research on deer vehicle collisions or bear sightings. We've seen an association between that suburban-urban interface where there's more deer vehicle collisions, where there's higher variety, basically more different types of pixels. If there is a pixel with just forest, we're not going to have a lot of deer vehicle collisions or animal interactions. And so kind of circling back to why we create quadrats or these squares in the first place is to look at interactions, typically physical, ecological interactions or mapping that don't necessarily need population data attached to them. So what I'm going to do with these quadrants, I'm going to highlight some of the neat things that we can do with this, and then I'll go and look at the developed land as well. So I'm going to click on this Zonal Statistics as table, and I'm going to double click on this. So this is the input raster or feature zone data. So this is that Durham fishnet, and I clipped it. I have a zone field called object ID. That looks like it's the only one that I have here. And then what I have here is the NLCD. We'll go back and do the developed in a little bit, but I can calculate all of the different statistics that we have here. All the different statistics. So we're looking at all mean, median, majority count, majority. Some of these are going to be useful, some of these aren't. When I look at something like mean or median, these aren't necessarily going to be useful because, like we said before, the Anderson classification scheme has nominal values, 10, 11, 21, 22, 23. That 21 isn't any better than the 10 or worse than the 23 or whatever. We can look at percentile values right here, but I'm going to run this. And let's see what we get right here. And this is the second one here that I have. So I'm going to right mouse click, open my table. And this is my table. So I've got an object ID, I've got a count. And if I were to just sort descending on the count, I've got 753. And like I said before, based on the projection of these data and the data from what I extracted these from the NLCD data database, we've got about a 40 meter by 40 meter resolution. So in 1 kilometer, we've got about 700 pixels, a little bit more than 700 pixels with some of these overlapping. And so you can see some of these pixels, because right now we're just looking at a table here. It's not attached to anything right here. And so that's going to change in a minute. So we've got a count. We've got an area in our map units. We've got a min. We've got a max. Like I said before, these min, max, ranges, even the means, the standard deviations, the sums, they're not going to mean a lot to me just because we're working with these nominal classifications. But one thing that I do like is variety. How many different pixels appear in each of these cells? Now we're going to have to refer to this cell using our object ID, or more specifically our object ID 1. We also have something called the majority count. Which one appears the most? How many times does it appear? And then what's the percentage of it? So 218 divided by 753, I bet is going to be 28.9509%. We also have a minority. Which one appears the least? So 31 appears the least. 31 is barren land only appears once within this particular cell, and it makes up 0.1328, which is 1 divided by that 753 number. And then median isn't going to be necessary here. Now I want to go and map these. So I'm going to uncheck this just because I don't want to make this map extremely busy. And what I'm going to do is I'm going to join these. Now some of the challenges that we see here, I see a 359, an object ID with an object ID 1. And if I were to kind of sort these, I'd see a 138. I kind of started to run into some problems here because these object IDs and these object ID 1s aren't necessarily matching up. And so I'm going to use this object ID 1 as this key for my fishnet. So I'm going to open my attribute table, and so you can see I've got an object ID and I've got an object ID 1 right here. I'm going to match these things up. Okay, so I'm going to run a spatial join. So I'm going to right mouse click. I'm going to do add join. So I'm going to look at object ID and then my zonal statistics 2. And I want to match it up with the object ID 1. Validate this join, and you can see it 847 versus 844. I assume, and a couple reasons, and I'm just going to kind of throw this out there, I assume we had some really small clips. We had some what we call slivers at the edge right here, which weren't big enough to accommodate a 40 by 40 meter. So we kind of had to go through and get rid of some of these. So now now we got this fishnet clip here. Now what do I have here? Now I've got a map right here for object ID 1. So now for this particular cell right here, you can see it's matched up to object ID using 3 as the reference right here. It's got a count of 749. That makes sense because it's not clipped at the boundary. It's got a variety of 11. It's got a majority of 41. It's got a majority count of 225 and 311. So now I can map these. Now, like I said before, a lot of these aren't necessarily going to be important, but I'm going to right mouse click and click on symbology. Okay, what I really want to map is this variety right here. To me, that's really important. So I'm going to go to my graduated colors. And now, since I have this, have the join created, I'm going to click on variety. What am I looking at right here? Now, these are the quadrats, and that have the most number of different land covers within it. So in towards the middle of the city, you can see I only have between 1 and 5. If I were to uncheck this here, you can see right in this area here, I only have between 1 and 5 different types of pixels right here, where if I go, further over here, these pixels right here, I've got some water, I've got some wetland, I've got some 21, 22, 23, which are your low, medium, high intensity developed lands, as well as some deciduous forest and some evergreen forest and some water right here. And I see this brown here, which might be some sort of grassland herbaceous or dwarf scrub. So we have this variety right here, which is really, really interesting here. And you can see these are going to be spatially related as well. So we've got spatial relationships with these as well. And now what we're looking at here as well is a feature class that has multiple attributes extracted from the raster data. Like I said before, some of these are not going to be very useful here, like the mean or the standard deviation, because we're working with nominal values in this raster calculator. These raster calculations are essentially, treating them as real numbers. Next thing I can do, I can go to my symbology here, and I'm going to look at the one that is majority. Okay, this one is going to be a little bit different. So I've got majority, and instead of graduated colors, I'm going to go to unique values. And I can color these in differently or whatever here, but now I can look at, okay, where's the majority here? I see over here, this is 21, and I can match these up with the colors. So these right here where my mouse is, the majority is a 21. I've got a majority of 11 right here. Let's look at my chart for 11. My chart says that this is open water. So now I can see my majority is 11 over here, which is going to be my, open water here. Over this way, it's going to be this purple, which is your 11 over near Falls Lake. That kind of makes sense here. Okay, Falls Lake, and then we've got some of these pink here's, which are 23, which are going to be your high intensity as opposed to your low intensity. And you can see this high intensity here as we get down towards the airport and going into Cary on the southwest side of Durham County. So this is extremely powerful tool that we're looking at right here. To me, extremely powerful tool. Next thing we'll look at, and I'll remove this join because I want to utilize this again, and I don't want to confuse myself too much. Okay. I'm just going to go back to single symbol. There we go. Okay. So now we have developed land. Okay, I'm going to do the same exact thing again, and the main thing I want to do is just interpret what it does. So I'm going to go to my tools. I'm going to go to my zonal statistics table, and now we have zeros or ones. And so my input is going to be my fishnet clip. My raster value is now going to be developed. And I'm going to calculate all statistics as well. And you're going to see some really neat things here. I run this. All right, let's see what we get. I'm going to run it again because all it did was It just ran it on that single one there, that single. All right, so once again, clip. A raster field is going to be my developed. Oh, okay. There we go. All right, let's get rid of this number 3 here. All right, now I have these 844. So now we're just working with these Booleans, these zeros and ones. So I have 0, 1, mean, standard deviation. The sum is going to be 412, and the majority count is going to be 412. So now my majority percentage here is going to be, well, this one has lots of ones, this one has lots of zeros, this one has lots of ones, this one has lots of ones, this one has lots of zeros. So I can calculate these or normalize these as a percentage minority. Now, since I only have 2 possible values, this is which we call Boolean, it's either my majority is a 1 or a 0. So 55.0802 plus 44.9198 equals 100. That's why I like working with these Booleans here. Now, once again, I'm going to join it, and I'm going to join it based on this object 1. So I'm going to right mouse click, and I'm going to go to my joins and relates. So I'm going to join my object ID with this Zonal Statistics 4 using my object ID 1. And I'm going to click OK since I think I'm right. Okay, so once again, we're going to join it. And you can see the extra object ID 1 is just a brand new object ID that was extracted from the existing object ID and just added to kind of get rid of some of the slivers that may have existed with our previous layer. What I have right here, once again, is now I can right mouse click, go to symbology. All right, this time I'm going to look at my graduated colors. Instead, I'm going to look at my sum. Okay, so now this is the sum. This is where all the ones are going to add up. All these ones are going to add up. Okay? So everything with the most amount of ones. Now the problem that you see is we have some issues with edge effects right here because this one has a whole lot of ones, but since it's clipped, it's not going to be 753. It might be, 327 out of the 350, but these are some of the edge effects that we're going to have right here. So we can sum we can sum this and normalize by the count. And so now we can look at these as percentages because count represents the total number of pixels within each cell, and the sum just adds up the zeros and the ones, zeros which are false, 1 which is true. And so once again, we get rid of these edge effects, which I think a lot of people run into from time to time when we work with these data here. So in conclusion here, the zonal statistics tools are extremely powerful so that you can go between your vector data and your raster data. In this particular case, I created a fishnet or a lattice. I ran some zonal statistics. I created some really powerful maps so that we can associate and group majority, percentages, and associate those with like distance to the nearest water or other phenomena that can be captured at the quadrant level.